Good day, everyone. I am your tutor for today. I am Jhon Rozano, and today we'll be discussing about the special polar curves. So first, let us have a recall about the limason. The limason has the form r equals a plus minus b cosine theta, or r equals a plus minus b sine theta, where a and b are greater than 0. In terms of its symmetry, if we replace r comma theta by r comma negative theta in the equation of r equals a plus minus b cosine theta, we get r equals a plus minus b cosine of negative theta, which is equivalent to its original form, which is a plus minus b cosine theta. This is because the cosine function is an even function. Therefore, these polar curve equations are symmetric about the polar axis, as you can see in the figure. Then replacing r comma theta by r comma pi minus theta in the equation r equals a plus minus b sine theta, we have r equals a plus minus sine of pi minus theta, which is equivalent to a plus minus sine theta. Sine of pi minus theta here is equal to sine theta, and it is one of its identities. Therefore, these polar curve equations are symmetric about the pi over 2 axis. As you can also see in the figure 1.2. Okay, then given a polar curve with equation of the form r equals a plus minus b cosine theta, or r equals a plus minus b sine theta, we say that the curve is a limason with a loop if a is between 0 and 1. It is cardioid if the ratio of a and b is equal to 1. If it is a limason with a then if the ratio of a and b is greater than 1 but less than 2. And it is a convex limason if the ratio of a and b is greater than or equal to 2. A polar curve with equation of the form r equals a cosine of n theta, or r is equal to a of sine of n theta, where a is greater than 0 and n is an element of any natural number, is called a rose. The following are the properties of a rose. Each petal of a rose has a radius a. This is because the range of sine theta and cosine theta ranges from -1 to 1. So the absolute maximum distance of a point on the polar curve from the pole is given by a, which is its radius. If n is even, the rose has 2n petals. It is symmetric about the polar axis, the pi over 2 axis, and the pole axis. And it can be traced exactly once as theta varies from 0 to 2 pi inclusively. On the other hand, if n is odd, the rose has n petals. It is symmetric about the polar axis if the equation is r equals a cosine of n theta, and it is symmetric about the pi over 2 axis if the equation is defined by r equals a sine of n theta. And it can be traced exactly once as theta varies from 0 to pi inclusively. Then, in terms of tangent lines to polar curves, we know that from the Cartesian equation, we have x equals r cosine theta and y equals r sine theta. Therefore, if you have a polar curve equation function in terms of theta, that is r equals f of theta, we have x over cosine theta equals f of theta, which implies that x equals f of theta cosine theta. So basically, we just substitute the value of r, which is f of theta, to either x or y. And similarly, we have y equals f of theta sine theta. This is called the parameterization of the equation of the polar curve. Then, getting the slope, this is given by m equals sine theta multiplied by the derivative of r with respect to theta plus r cosine theta all over the cosine theta multiplied by the derivative of r with respect to theta minus r sine theta. Given that the derivative of x and the derivative of y with respect to theta are both continuous, and the derivative of x with respect to theta is not equal to 0. Additionally, in case that both the numerator and the denominator of m are 0, at theta equals theta sub 0, then the slope of the tangent line when theta is equal to theta sub 0 is given by the limit of sine theta multiplied by the derivative of r with respect to theta plus r cosine theta all over the cosine theta multiplied by the derivative of r with respect to theta minus r sine theta as theta approaches theta sub 0. So for the first problem, what is the equation of the tangent line to the polar curve r equals 4 plus 9 cosine of the absolute value of pi minus theta at theta equals 3 pi over 2. So first, observe that pi minus theta is less than 0 when theta is greater than pi. So since our theta here is 3 pi over 2, it is actually greater than pi. So we have pi minus theta is less than 0. Therefore, the absolute value of pi minus theta is equal to theta minus pi. Okay? So we have r equals 4 plus 9 cosine of theta minus pi. Therefore, substituting the value of theta equals 3 pi over 2 to this equation, we get r equals 4 plus 9 cosine of 3 pi over 2 minus pi. Then, evaluating this equation, we have 4 plus 9 cosine of pi over 2, and since cosine of pi over 2 is equal to 0, we get that r equals 4. Therefore, the point of tangency is at r comma theta, that is 4 comma 3 pi over 2. Moreover, getting the slope of the tangent line, we first get the derivative of r with respect to theta. And that is given by negative 9 sine of theta minus pi. This is because from this equation, since we are getting the derivative of r with respect to theta, we get that the derivative of cosine of theta minus pi is just negative sine multiplied by the derivative of theta minus pi, since by chain rule, we have 1. Okay, so we get negative 9 sine of theta minus pi. Therefore, using the formula for the slope from the recall, we have m equals sine of 3 pi over 2 multiply the derivative of r with respect to theta plus 4 cosine of 3 pi over 2 all over cosine of 3 pi over 2 multiplied by negative 9 sine of pi over 2 minus 4 sine of 3 pi over 2. So simplifying this one, sine of 3 pi over 2 is equal to negative 1. Negative 9 multiplied by sine of pi over 2 is equal to negative 9. So you have negative 1 times negative 9, that is 9. And for cosine of 3 pi over 2 is 0. So you have 9 in the numerator. Then from the denominator, we have cosine of 3 pi over 2 is 0. So this will be cancelled. Minus 4 of sine 3 pi over 2. Sine of 3 pi over 2 is equal to negative 1. So negative 4 multiplied by negative 1 is equal to positive 4. So all over, you have 9 divided by 4. So that is our slope. Then, obtaining the Cartesian coordinate, we know that x equals r cosine of theta. Substituting the value of r and the theta, we get x equals 4 cosine of 3 pi over 2, which is 0. On the other hand, we have y equals 4 sine of 3 pi over 2, that is equal to negative 4. Therefore, using the point slope form, our equation of the tangent line and the polar curve at 4 comma 3 pi over 2 is given by y equals 9 over 4x minus 4. So for the next problem, consider the polar curve whose equation is given by r equals cosine of a theta all over a plus 1, where a is greater than 0, fix theta such that theta is an element of 2k plus 1 all over 2 multiplied by pi, where k is an element of natural number, including 0, find the values of a for which the tangent line to the rows is horizontal, vertical, and not vertical nor horizontal. Okay, since we are focusing about the slope, whether it is horizontal, vertical, or not vertical nor horizontal, then we get that when the slope is 0, that is, the tangent line is horizontal. And when the slope is undefined, our tangent line is vertical. Okay, so here we get first the derivative of r with respect to theta, and that is negative a sine a theta over a plus 1. Okay? So, kinuha na natin yung derivative dito. And since yung a plus 1 natin sa denominator, it is just a constant. So, ang i-derive na lang natin ay yung cosine a theta. So, that is negative a sine a theta. Therefore, using the slope formula, we have the following equation. Okay, m equals sine theta multiplied by negative a sine a theta over a plus 1 plus cosine a theta over a plus 1 multiplied by the cosine theta all over cosine theta multiplied by negative a sine a theta over a plus 1 minus cosine a theta over a plus 1 multiplied by sine theta. Okay? Then, from this, observe that for theta is an element of this, cosine theta is actually equal to 0. And sine theta is an element of either 1 or negative 1. So, bakit? Notice that 2k plus 1 over 2 multiplied by pi, the numerator here is an odd number while the denominator is exactly 2. So this is in the form of pi over 2 multiplied by some number. So cosine theta is equal to 0, while sine theta is either 1 or negative 1. So we can see that sine theta is not equal to 0. And also, a plus 1 is not equal to 0 since in the given, a is greater than 0. Therefore, m will be sine theta multiplied by negative a multiplied by sine a theta over a plus 1 all over negative of cosine a theta over a plus 1 multiplied by sine theta. So basically, what we just did is to remove this cosine a theta over a plus 1 multiplied by cosine theta, and then cosine theta multiplied by negative a multiplied by sine a theta over a plus 1. This is because our cosine theta is 0. Okay, so this will be the simplification of our slope equation. Okay, so upon simplifying, we get a multiplied by sine a theta over cosine a theta. Then, observe that when a is even, that is for a equals to 2m for some positive integer m, a multiplied by theta is equal to 2m multiplied by 2k plus 1 all over 2 multiplied by 5. Then, factor out the common factor. We have 2mk plus m multiplied by pi. Okay? So, yung a theta dito, we just multiply this to theta. So, yung theta natin ay ito originally. Then, since our a is even, we get 2m multiplied by this equation. Okay? So, observe that sine a theta is equal to 0. And cosine a theta is not equal to 0. This is because we have some number multiplied by pi. And its sine value is equal to 0, while its cosine value is not equal to 0. Therefore, the tangent line to the rows is horizontal since our m here will be 0. This is because sine a theta is actually 0. Okay? So we get that when A is even, the tangent line to the rows is horizontal. Okay? Now, observe on the other hand, if A is odd. That is, A equals 2n plus 1 for non-negative integer n. Then, our A multiplied by theta will become 2n plus 1 multiplied by 2k plus 1 all over 2 multiplied by pi. And that is equivalent to 4nk plus 2n plus 2k plus 1 all over 2 multiplied by pi. So just use the FOIL method here so you can arrive to this form. Then we can factor out the 2 from 4nk plus 2n plus 2k. That will be 2 multiplied by 2nk plus n plus k plus 1 all over 2 multiplied by pi. So in this form, we can actually see that this is 2 multiplied by some number plus 1 all over 2 multiplied by pi. So we can see that sine A theta is not equal to 0, but cosine A theta is actually equal to 0 because this is in the form of pi over 2 multiplied by some number. That is actually n. So we have m equals a sine A theta over 0. So this can either approach to positive infinity or negative infinity. Therefore, the tangent line to the rows is vertical when A is odd. And lastly, if the tangent line is not vertical nor horizontal, then we can just exclude from what we have achieved previously, right? A is neither an odd nor an even integer. That is, A is not an integer. So A is part of real number, but A is not an integer. Therefore, we have, for the first condition, if we want our tangent line to be horizontal, we have A equals 2k, where k is an element of natural number. Second, if we want our tangent line to be vertical, then we get the values for A, that is A equals 2n plus 1, where n is an element of natural number, including 0. And lastly, if we want our tangent line not to be vertical nor horizontal, then we get A is an element of positive real number and is not an integer. Okay, that is all. Thank you, everyone.